All right, hello students. We're gonna go ahead and move forward on now to lesson 19. Do some comparison shopping, um, unit unit price, and related measurement conversion. So we're gonna start kind of comparing things, unit rates and unit pricing. So let's go and look at kind of what we're doing. So in this lesson, we're going to be analyzing tables, graphs, and equations in order to compare rates. So we're going to be kind of analyzing or looking at these three different types of items: tables, graphs, and equations. All right, so let's go and look at example 1 and kind of see what they have us doing. All right, here you go. The ratio of cups of blue paint to red paint is 1 to 2. So that's our ratio, which of course means for every cup of blue paint, there are 2 cups of red paint. In this case, an equation would be red equals 2 times blue. Or in math, we like to kind of get rid of these words and use symbols or variables, or R equals 2 times B. Now that means multiplication written next to each other like that, where B represents the amount of blue paint and R represents the amount of red paint. Make a table for the values. Well, let's go and underline some important pieces of information. First, they give us an equation of red equals 2 times blue, or R equals 2 times B. And remember, this right here means multiplication when they're just sitting next to each other like that. All right, so let's go ahead and fill out our table. Well, first, let's go and write down the 2 items we're talking about. First, we're talking about blue paint. So let's go and write blue here. And the second one, or the second piece, is red tape. So let's go ahead and write red here. The other important piece of information that we want to write down is this equation, because to get the red, we can use the equation of 2 times blue, or 2 times B. And of course, I'm going to write it in the variable form that is presented or given to us. So the blue, I can put whatever number I want for blue. I should be able to develop the red column. So for blue, if I simply have 1 cup of blue, I can plug that in. Now this is I'm just choosing any number I want to for blue. 1 times 2, of course, is 2, so that means I have 2 cups of red. If I have 2 cups of blue, I can plug that in. 2 for B, right? 2 times 2 gives me the 4 for red. If I keep going, let's go ahead and go with 3. 3 times 2 gives me 6, so I have 6 cups of red. And the next one, if I put 4, of course, 4 times 2 is 8, so I have 8 cups of red. Now, I kind of did a nice, neat order, just simply went up by ones on the blue. I can choose any number I want to for blue, and I should be able to develop an answer for red. So let's go ahead and look at kind of another number. Let's go ahead and put 15 over here. Well, what happens if I have 15 cups of blue? How many cups of red would I have? Well, I can plug it into my equation. 15 cups of blue goes in for B. So 2 times 15 gives me 30. I would need 30 cups of red. All right, so that's kind of how we use the equation to help kind of develop or make up a table to help us do some comparisons. All right, let's go ahead and stop the video, go and move on to the next one. We're going to use a table and graph to compare 2 items or 2 individuals. All right, hello students, let's go over another example. This time we're actually going to compare 2 individuals based on a table and based on a graph. So let's go and look at some information given. All right, Brian and Shanice are both training for a bike race and want to compare who rides his or her bike at a faster rate. Both bikers use apps on their phones to record the time and distance of their bike rides. Brian's app, keeps track of his route in a table. So here's Brian's table. And Shanice's app represents her information in a graph. So here's Shanice as information, as the information shows below. All right, so this is just simply some information provided. We actually haven't come to a question yet, but we're going to compare this table and this graph together kind of on the next 2 parts. So let's go ahead and look at what they're asking us in the next part. Here, part A. At what rate does each biker travel? Explain how you arrive to your answers. So we got to explain how each biker travels. So let's go and get out a pen Let's go ahead and kind of write down the two bikers we're talking about. We're talking about Brian. I'm just going to simply put B for Brian. And the other biker, I believe, was Shanice. So let's go ahead and put Shanice over here. And let's go ahead and see what kind of information we got. Well, if we're going to compare, remember, we have to compare, we have to have the same amount of time. So if we look at this, Brian has 0. Well, 0 doesn't really help us because they haven't traveled anywhere. We have 3 hours and 75 minutes and 6 hours and 3 hours, 75 miles, excuse me, and 6 hours, 150 miles. Well, over here, we have 3 hours here, we have 3 hours here. Well, there's a little dot there, but it's in between two numbers. We can't tell exactly what that is, even though it does look to be about 45. So we could compare those, but to help, we're going to simplify and use a unit rate. So let's go ahead and kind of talk about or use a unit rate. Well, Brian, we know, goes 75 miles in 3 hours. So let's go ahead and put the times and then miles. Well, if I simplified that down, I would have to divide both top and bottom by 3, and that would equal, well, 75 divided by 3 is 25. We're talking about 25 miles per hour, or 25 miles in 1 hour. Okay, now we can use the word per, we can use the slash in 1 hour because 3 divided by 3 is 1. Remember, I'm just simply dividing by the bottom. If I went up to, the graph now and pulled a dot. Now I could use this, but that's in between. I don't really know where that is. What I want to find is something that kind of goes along both lines, like this one right here does. It goes along both lines. That way I get an accurate amount. I don't want to take a guess because my guess might be wrong. I want to find an accurate amount. And this goes on both the x-axis and the y-axis. So it tells me that I have 2 hours. And she goes 30 miles. So let's go ahead and scroll back down. So let's go ahead and do her work now. Well, she goes 30 miles. And it takes her 2 hours. So I can't compare. Remember, I can't compare these two because this is 2 hours. This is 2 hours, and this is 3 hours. I have to compare the same time. So if I was to simplify this to a unit rate, I would divide both of them by 2 because I'm dividing simply by the bottom number. 30 divided by 2 is 15, and of course this is 15 miles per hour, or in 1 hour. Okay, and that of course is a unit of speed. All right, well, I found the rate. Does each biker travel? I found that, and Brian goes 25 miles per hour, and Shanice goes 15 miles per hour. Now it says, explain how you arrived at your answer. Well, what did we do? So let's go and actually answer the question. To find the rate of each biker, we found the unit rate by dividing was it distance or miles by time. All right, so I did the work and I was able, now I have something I can compare, and I can see that Brian is going a lot faster than Shanice. And now I give an explanation of what I did. To find the rate of each biker, we found the unit rate by dividing mile by time. I apologize for that. All right, so that's part A. Let's go and look at part B. Shanice wants to win the bike race. So she wants to beat Brian, but of course she's going too slow right now. Make a new graph to show the speed Shanice would have to ride her bike in order to beat Brian. Well, she has 15 miles per hour. She needs to go over 25 miles per hour. So we have to pick something that's greater than 25 miles per hour. So we can use anything that's greater than 25. Well, I'm going to kind of use a nice round number. I'm going to use 30. I'm going to show that Shanice needs to go 30 miles per hour to beat Brian, just to give a little extra extra help to her to show that she's going to be faster than he is. So let's go and make our graph. Well, first we need to label our graph. Well, first the bottom part, just like above, let's go and look above here. This is number of hours here, the x-axis. So let's go ahead and do the same thing down here. This is number of hours. And over here on the side, just like above here, this is number of miles. So let's go ahead and put number of miles. Oops, let's go and use this number sign, number of miles. There we go. So now I have to put numbers. Remember, these are number lines, so I need to put numbers here. Well, the hours should be pretty easy because, let's go ahead and get off that. Because it just simply needs to go up by 1. This right here, of course, is 0. That's where all number lines are going to start. As we go up the hours, it needs to go by 1. 1, 2, 3, 4, 5. We're just going to stop right there at 5. The miles is going by 30s. Well, I need to go up by 30. So I couldn't go by 1s up here since this is number of miles. I would have to go by a bigger number than 1. I could go by 5s. I'm going to go by 10s. I think that would be a good number. So it should give me a couple dots. So if that was 10, then this would be 20. This would be 30. Let's keep going. This is 40. Let's go ahead and go up to 60. This is 50. Let's go and go one more dot. This is 60. Or one more number, excuse me, that's 60. All right, so based on this, I should be able to make a couple points. Well, if Shanice is going to travel 30 miles, right, if we make a little table here, if she's going to travel 30 miles, how many hours must she go? Well, for every 30 miles, she goes 1 hour. So let's go ahead and go 1 hour. So this is our point. So this is our point. We have X's number of hours is 1, and then of course we have 30. Okay, so let's go ahead and plot our point. So let's go and grab a different color to plot. So number of hours is 1. How far she goes is 30. So let's go ahead and plot our point right here. Let's go ahead and even label it 1:30. Hopefully this is a nice little review of how to graph. Of course, remember, if she doesn't go anywhere at all, or she doesn't do anything at all, she doesn't go anywhere. So that'd be 0, 0. I'm just going to kind of put that in there. Of course, if she wants to go 60 miles, how many hours would she have to go? She would have to go 2. So 2 hours and 60 miles. So that should give us our second dot. So let's go ahead and get our red pin out again and go for 2 hours. She goes all the way up to 60 right here. Okay, so let's go and label that. We have 2 hours, 60. Now, of course, I'm putting the 2 hours first because the x-axis comes first, y-axis comes second. And now we should be able to draw a line or draw a graph. Please forgive me, I'm going to draw this with the mouse, so it might not be as straight as it should be, but it should be pretty close. All right, so for Shanice to win the race, this is the graph that should look like. For every 1 hour, she'd have to go 30 miles, 2 hours, 60 miles, and so forth. All right, so based on the information, you should be able to try to do the next problem. Go ahead and close the video and go ahead and start working with your partner.